Hi guys, we're gonna look at problems from chapter 5 today. Sometimes what can happen with some of these problems is even though you might know the theory and the definitions, to actually look at the problem, decipher what it's asking, and apply your knowledge to it can get a little tricky sometimes. So I've picked a couple problems from this chapter that I thought might be good practice, and I will solve them over here, and I hope that this helps you. Okay, so to start, what I'm going to do is problem number 5 from chapter 5. Okay, here's what it says. A filling station is supplied with gasoline once a week. If its weekly volume of sales in thousands of gallons is a random variable with probability density function given by f of x equals 5 times 1 minus x, all of it raised to 4, when x is between 0 and 1, and 0 otherwise. So this is the density for the weekly sales in thousands of gallons. What must be the capacity of the tank so that the probability of the supply being exhausted in any given week is 0.01? So what are you being asked? What must the tank capacity be? So how large should the tank be so that the probability that the gas in the tank is less than the sales? This probability is equal to 0.01. So that's the question. The question says, what must the capacity of the tank be so that the probability of the supply being exhausted in a given week is 0.01? Okay, so that's the question. Now let's apply what we know about the sales. What do we know? We know that the density of the sales is 5 times 1 minus x to the 4th when x is between 0.01. So we need to find this number, the volume of the tank. So we want the probability that the volume of the tank is less than the sales. We want this probability to be equal to 0.01. But this sales, that's a random variable. The volume of a tank, that's fixed. We need to try and find out exactly what should this V be so that this random variable is 99% of the times smaller than the volume. So for most of the times, you're not going to run out of gas. Okay, so we need to find a number. I'm just going to rewrite it in the other order. The probability of sales, let's just call volume V. The probability of sales bigger than V is equal to 0.01. We want to find V such that this is satisfied. Well, what do you know about sales? Sales has this density, f of x given above. Okay, all right. So how can we calculate this? Well, we know that the probability, let's call the random variable x, is the sales in a week. Okay, we know the probability x is between A and B. Well, let's just assume A and B are between 0 and 1 in thousands of gallons. This probability is given by the integral from A to B of the density dx. Okay, so what are we wanting over here? We want to find v such that the probability x bigger than v is equal to 0.01. All right, so you can also write this in a different way. This is the same as saying probability x less than, it's a continuous random variable, so it doesn't really matter whether you put greater than or equal to or less than or equal to. Probability x less than or equal to v, that's the complement, is 1 minus 0.01, so that's 0.99. So now we need to find a v such that the probability sales is less than or equal to v is 0.99. Well, certainly the sales is going to be bigger than 0, so let's just write that, or bigger than or equal to 0. And you want to find a v such that this is 0.99. Well, what is this? That is going to be the integral from 0 to v of the density. So we're going to find a v such that this happens. Okay, so that is integral from 0 to v. What's the density? Density is 5 times 1 minus x raised to 4 dx. And you want this to be 0.99. Okay, so we need to do this integration. What will that be? 5 times 1 minus x raised to 5 divided by 5. And we need to divide it by -1 because of u substitution. So let's just put a minus over here. And that goes from 0 to v, and you want that to be 0.99. Okay, so now it's just a basic algebra question. Okay, you plug in 0 first just because of the minus over here, and you have 1 minus v raised to 5. You want that to be 0.99, or 0.01 needs to be 1 minus v raised to 5. So 1 minus v is the 5th root of 0.01, and v is 1 minus the 5th root of 0.01 in thousands of gallons. And clearly, I mean, this number, that's a positive number. So you know 1 minus that is a number smaller than 1. I mean, clearly that's smaller than 1. So you know this is not some number between 0 and 1, probably very close to 1. And you don't need the tank to be the maximum of where the density is non-zero. You don't need the tank to be 1,000 gallons. It's enough if the tank is having this volume in thousands of gallons and the probability of running out is then 0.01. Okay? So I hope this problem made sense. The main thing over here, what we needed to do is interpret the question which says what must the tank capacity be in order for us to not run out of gas 99% of the times, or with probability 0.99. Okay? All right. You can let me know if you have any questions. Of course, I can discuss this with you in class too, if you need any further help on this. Okay. So we're going to do one more problem now, and that's going to be problem number 20, but I'm going to adjust the numbers a little bit. Okay? What this says is if 65% of the population of a large community is in favor of a proposed rise in school taxes, approximate the probability that a random sample of 100 people will contain at least 60 who are in favor of the proposition. So, 65% of the population in a large community is in favor of the proposed Rise in school taxes, you want the probability that if you have a sample of 100 people, what's the probability that at least 60 are in favor of the proposition? Okay, so let's try and figure this out. What do you have? You have 65% in general are in favor. There's a total 100 people in the sample. And you want the probability that at least 60 are in favor. Okay, so let's suppose that X is the number of people who are in favor of this proposition. What kind of random variable is X? What do you think? Well, you have to assume independence, okay? You have to assume that everyone thinks for themselves. They're not swayed by their neighbor or anyone around them. And with that assumption in mind, you know that the random variable X, that will be a binomial random variable with n equals 100 and p equals 0.65, which is the probability of being in favor. So this X now is the number of people who are in favor. That's this random variable. What is the question asking? The question asks for the probability that X is bigger than or equal to 60. Okay. So, if we were to actually do binomial, that would get pretty tedious and tiring very quickly. We'd have n choose 60, p raised to 60, 1 minus p raised to 40, then do the same with 61, 39, all the way till 100 and 0. And that's going to be a giant sum, and we don't want to deal with that. So what can we do in this situation? Well, if you take a look at these numbers, n is pretty large. P is 0.65. It's not a minuscule number, so it's not a question about a Poisson approximation. And what do you have? You have n times p, that is 65. And you have n times p times 1 minus p, that is 65 times 0.35, and that will be 22.75. Okay, now with these numbers, you know what can you do? You can approximate this binomial random variable with a normal random variable. Okay, so that's what we're going to do. And normal random variables, it's easy for us to calculate. We have our normal tables, and we can just find out exactly what the z-value is and figure out what this probability is. Okay, so we want the probability X is bigger than or equal to 60. Well, X is binomial, n equals 100, p equals 0.65. All right, the probability X is bigger than or equal to 60. So let's see, suppose you have the bar of X equals 60. Okay, here I'm showing you the probability mass functions for the binomial random variable. Okay, and then next to it you have the bar for the probability X equals 61. The area of each one of these bars is the appropriate probability. And then you have the probability of X equals 62, and so on. What we want is the probability X is bigger than or equal to 60. So all of this onwards all the way to the right till 100. But since we're doing normal approximation, we can ignore that because the area under the normal curve to the far right is so little that we can just ignore that. So we want the probability X is bigger than or equal to 60. So what do we want? We want the area, so you having approximation by normal, we want the area under this curve really to the right of the left end of this bar, which is 59.5. Okay, or if you want, you can think of this is a discrete random variable. The probability it's bigger than or equal to 60, of course, that's the same as it's bigger than or equal to any number between 59 and 60. Okay, so here we're going to put 59.5, like I explained because of the histogram you have here. And what do? You subtract the mean from both sides. What's the mean? This is the mean. Mu is 65. I'm just going to write mu right now. And you divide it by the standard deviation. I'm just going to write sigma right now. Okay. Well, what is mu? Mu will be NP. So that's 65. Sigma squared is NP times 1 minus P. So that is 22.75. Okay. So what do we need? So this will be the probability. Now x minus mu over sigma, this will be approximately probability z bigger than or equal to 59.5 minus mu. What's mu? That's 65. There's a line already over here. Divided by square root of 22.75. Okay. What will this be? This is approximately probability z bigger than or equal to, that's negative 5.5 over approximately 4.77. You can calculate it. This is approximately negative 1.15. So what's the probability? Z bigger than or equal to negative 1.15. Okay, so using the normal tables, what will this be? In our book, the normal tables just give us the phi values for positive numbers. So what do you have? You have your normal random variable. Here is positive 1.15. We have negative 1.15. We want this whole area. Well, the probability is z bigger than or equal to negative 1.15. That's the same as the probability z less than or equal to 1.15, which is the phi value for 1.15. And under the table, you can see 1.15 is 0.8749. So this is the approximate probability that you have at least 60 people in favor of raising taxes. All right. I hope that made sense to you guys. Okay. And if you have any other questions that you've tried from chapter 5 and would like me to either give you a hint on the answers or, first give you a hint and then maybe give you the answer after, I can do that. Feel free to email me and I will send you some solutions. And of course, we can discuss any of this in class. All right, guys. Well, have a nice day and I'll see you soon. Bye.